Welcome to today's video. Today we're going to be talking about and defining the segment addition property. We're going to show that mastery in class by scoring at least an 80% on the exit tickets. Now make sure you have the note sheet in front of you. If you don't, take out a separate sheet of paper and we'll get you a fresh copy tomorrow. The first thing we want to start with is we want to start talking about some vocab because we're going to hear these words time and time again, and I want to make sure we understand what they are. A point is a location represented by a dot. And I know that seems simple, but we want to make sure that we understand the difference between it. A point is a location represented by a dot. Every point has a name. It is a letter. Now, depending on the problem, you could have multiple points with multiple different letters, but a point is always represented by a letter. A line is made up of points. It has no thickness and no width. You can have a line that goes through 2 points, it can go through 3 points, it can go through 10 points. It does not matter how many points it goes through. But the important thing is it does not matter how thick it is or how wide it is. Now, the difference between a line and a line segment. A line segment is part of a line that consists of 2 endpoints and the points between them. So a line can go on forever in both directions, where a line segment has a starting point and a stopping point, and those are our endpoints. We've talked about those with midpoint and we've talked about them with distance, but each part of that is a line segment. Now, as far as midpoint, it is the point on a segment halfway between. Halfway means we have 2 equal parts. You're dividing it by 2. Your distance is the length of a segment between those 2 points. And it's important that it's the length of a segment. It is not just the length of a line, because a line can go on forever in each direction. It is the length of a segment. Finally, the most important word you'll hear throughout this entire year is congruent, and they have the same measure. We can have congruent angles, congruent shapes, congruent line segments, but they have the same measure. Now, when we talk about segment addition, the important thing to keep in mind is we have 2 parts of a segment that are going to make a whole segment. And if we look, line LKJ is broken apart into 2 sections. Now, K is not the midpoint. You can tell by looking at it, but we want to also find out what X is. If we look at the blue line at the bottom, it gives us a starting point and an end point. And if you notice, my top line, LKJ, is the same length as the bottom. So if they are the same length, that means those 2 parts are congruent. If they're congruent, they equal each other. Now, the thing we have to remember about the top is we have 2 parts that equal 1 whole part. Well, if we have 2 parts, that means we need to add them together. So in this case, we're going to write out our equation, x plus 19 plus x plus 22 equals my bottom 19. My whole segment is on one side, and the other parts are the individual parts of the line segment. So now if I combine like terms, x plus x gives me 2x, 19 plus 22 gives me 41 equals 19. From here, we're just going to use 2-step equations to solve. 2x is going to equal negative 22. Well, if I solve that, divide by 2, x is going to equal negative 11. Now, the important thing to keep in mind, x is negative 11. Yes, we cannot have a negative line segment, but we just found x. If I plug it in, negative 11 plus 19 gives me a segment of 8, and negative 11 plus 22 gives me a segment of 11. Well, if I take those 2 values and add them together, I'm going to get the length of 19, my bottom line segment. Now, if we look at our second question, again, we're solving for x. And it's important to read these questions because sometimes they may have you solve for a line segment like JK or the full length of the line segment. But in this case, we're still just solving for x. If we notice, I have that line segment JKL, and minus the fact that I can't draw a straight line, it is the same length as the bottom line segment. So they are congruent. So again, our 2 line segments equal each other. Well, that means JK plus KL has to equal my bottom part. So I'm going to write it as x plus 1 plus 5 equals 2x minus 4. If I combine my like terms, we get x plus a funny looking 6 equals 2x minus 4. So if I subtract x on both sides and solve it like a normal multi-step equation, I get left with x is equal to 10. Now, one way to check ourselves to make sure, if I plug 10 back in, well, 10 plus 1 equals 11, and 11 plus 5 equals 16. Well, if I plug x into the bottom, because x is the same, it doesn't matter which line segment you're looking at, I have 2 times 10 minus 4. Well, 2 times 10 is 20 minus 4, and that equals 16. And that's important that both of those numbers equal each other because they're congruent line segments, and congruent means they have the same measure. So if we don't get the same number out, something went wrong and we need to go back and double check all of our work. If we look at the third example, again, we have line segment JKL and we have a congruent line segment at the bottom. So we're going to add them together. 10 plus 2x minus 14 equals x plus 8. So I get 2x minus 4 equals x plus 8. And in the end, I get x is equal to 12. So now again, we do want to make sure that we're correct. We're going to go back and check our answers. Well, 10 doesn't have any variables. Here I have 2 times 12 minus 14, which is 24 minus 14, which equals 10. And if I add those two together, I get an answer of 20. If I put 12 in for my x here, 12 plus 8 equals 20. I have two congruent line segments, so that means my value of x is correct. If we look at example 4, again, we have line segment L, M, and N. Doesn't matter the points that are on my line segment, it's still a line segment. M is still between L and N. So we're going to solve for our value of x. In this case, we're going to add it together again. It's going to equal my bottom congruent line segment. So 2x minus 17 plus 2x minus 12 equals 15. Got to combine like terms. 4x minus 29 equals 15. Add 29. X is going to equal 11. And again, go back and check yourself. It doesn't take much to check yourself, but it's a guaranteed answer then. First, the question asked me to solve for x. Well, I solved for x. Now, to double check that x is correct, we have to do 2 times 11 minus 17. Well, 2 times 11 is 22, minus 17 is 5. Over here, we have 2 times 11 minus 12. Well, 2 times 11 is still 22, minus 12 is 10. 10 plus 5 gives me 15. And if I look, my bottom line segment had a value of 15, so those are correct. But you need to make sure to go back and check yourself, because sometimes you're going to set up the problem right and you might make a mistake in your algebra. Well, we don't want a wrong answer just because there was a mistake in your algebra. So please make sure you go back in and double check all your answers. In question 5, again, we're solving for x. We have our line segment QRS. So now we want to be able to combine them. We have x plus 20 plus x plus 23 equals 21. I'm going to combine like terms, and I get 2x plus 43 equals 21. Well, if I subtract 43, 2x is equal to negative 22. Again, we're dividing by 2, so x is equal to negative 11. And again, it's important to remember, if you're solving for a line segment, you shouldn't get a negative line segment. We can't have a negative distance. But because we're solving for x, x can be negative. Now when I go to plug this back in, negative 11 plus 20 gives me positive 9. Well, that's okay. Negative 11 plus 23 gives me positive 12. That's okay. And 9 plus 12 gives me 21. And they are congruent to each other. So it's important to make sure that we double check. Make sure your answers make sense, that we don't have a negative value for a line segment. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.